This video is going to be about creating nuclei larger than Nickel-62. So in order to create elements larger than Nickel-62, because the fusion is energetically not favorable, we have to do something called neutron capture. So you can add neutrons to a nucleus easier than you can add protons, because neutrons are uncharged and can approach close enough to a nucleus for the strong nuclear force to add them and suck them in. So this diagram shows how that works. So a neutron is added to my target nucleus, which increases the atomic number by 1. My atomic mass by 1. But it doesn't affect my atomic number, which means I don't change the type of element I have, but I change the type of isotope I have. So the new isotope is unstable, so it releases a beta particle. When the beta particle is emitted, the nucleus loses a neutron and switches it to a proton. This means I increase my atomic number, which means I now have a different element, a heavier element than I started with. Gamma radiation is emitted throughout this process, here and here. Alright, now let's look at the two types of neutron capture. The first type of neutron capture is the S process. The S stands for slow. This can create heavier nuclides up to bismuth 209. This occurs in stars with a small production of neutrons, which are sometimes produced as a byproduct of making carbon, oxygen, and silicon. Nuclides need to have time to undergo beta decay before they undergo a second neutron capture. This process not only produces heavier nuclides, but it also produces heavier isotopes of the same element that you started with, often. The second type of neutron capture is R process. The R stands for rapid. This process can produce elements heavier than bismuth 209. The R process happens when there's insufficient time for beta decay to occur before neutron capture happens again in the same nucleus. This occurs in stars that produce a lot of neutrons. For example, type 2 supernovas. Supernovas can cause the conversion of a neutron to a proton, also because they produce a lot of neutrinos, which collide with neutrons to produce protons. Alright, that's the end. Thank you.